See how far that goes.
So this is the fifth degree. What's this?
Fifth.
Fifth? That's the fifth degree. And then, what kind of polynomial is this?
Binomial.
Binomial, because it's got two terms. So this would be a sixth degree binomial. Okay, I like it. How are you guys doing? All right, I know, not the most exciting material that's ever existed, but still, you just have to be able to identify these things, right? Okay, maybe. All right. So today, we're going to pick up where we left off last time. We just barely started getting into the first form of factoring. So what we're going to do, just give you an overview, we're going to talk about all the different forms of factoring. And then I'm going to give you a sheet that's going to have all the forms of factoring explained. And at the top is going to be a quick reference guide about when to do what. Because one of the hardest things in math is when to do what, right? I know how to do that, I just don't know when. That's I hear that all the damn time. I can totally relate. So let me remind us how far we got last time. We talked about something called, anybody remember what it was called? It's got a 3-letter, a quick way to reference it. GCF. I like it. Yeah. I was going to say greatest common factor. I'll never write that out again. It's GCF. And if you break it down, the name tells you what to do. The greatest, the biggest common thing that is a factor for each piece. So what I mean by that is this. So for example, if I saw 8x plus 16, is there a factor that both of those terms have? So I'm going to write more than I really have to, just to really show you what's going on. 8x is 8 times x. That's amazing, Jeff. 16 is 8 times 2. So do you see how the right way to look at GCF is, what was distributed in 8? Let me take it back out. What would it have looked like before I distributed the 8? So we're just working, and we know that's what factor means. If I said factor 18, what would you say? What's one way to factor 18? 9 times 2, right? So that's what the problem would have looked like before somebody multiplied it. So 18 would have come from 9 times 2, or from 3 times 6, right? Or even from 18 times 1, right? Ooh. So if I take an 8 out, what's left? X plus 2. Ouch. So how do you check this kind of work? How do you check any factoring problem? You multiply it back out. You make sure you get back up. 8x plus 16. Bam! Yeah. How do we know so far? Hopefully this sounds familiar to most of us. Let's see. So let's make a more interesting problem. What we got, Jeff? All right, I like this one. So it doesn't matter how many terms there are. The thing I write out front has to be something that everybody has. The greatest. So I could have taken a 4 out, couldn't I? That's not the biggest thing. I would have had to do multiple steps, which is fine, but you try to avoid it. Common, everybody's got to have it, or else how the hell is it going to come out? Factor, it's got to be something that multiplies as a part of it. Yes?
That's fine.
Beautiful. So for the numbers, I like it. Chris is like, hey, don't talk. I've solved the problem. So for the numbers, they all have a 5. So far, so good.
Why?
Letter-wise, they all have a Y. Can I take an A out?
No.
No. This ain't got no A. But every single one of them has got at least one Y. If you try to take 2 Y's out, these first 2 are 5, this guy's going to freak out. I don't like being alone. That's a weird confession to make. So what happens? So now each piece. Do you see how now watch? This is a little thing. This is a little thing, but it's huge. That sounded weird. If I put that over a little bit, I can put right underneath each term what's left. That way I don't leave anything out. So what's left here? 15 divided by 5.
Y squared.
There's a 3. Y squared. 2. A had 2 y's, took 1. 1.
Plus 4A.
Yeah, plus 4. Took a y out, so it's gone. Bam. How do I know I'm done? Because none of these have anything in common with each. It has no y's, that has no a's. 3, 2, and 4 don't share anything.
So if all these factors, we should call it segregation.
There might be reasons why we don't call it. Alright, I like it. Start. Okay. So what about, let me see if I can up this. Alright. I like it. Try to do that one.
Would you like to leave variables by themselves and then just distribute the number into them?
You're trying to, like, undistribute.
Yeah, but I'm saying like with the problem, you can take out 4
Yeah,
with the last one.
Yeah,
You can do that.
you can take a 4 out, yeah. You can take a 4 out of everybody, right?
Yeah.
Yeah.
Okay.
So that's going to be a part of what I write out front. So out front I'm going to put 4. Now look at the letters. How many G's going to take out?
G squared.
2. So you see how, real quick, the variables are always whatever has the lowest power. That's what you take out, right? So you take out 2 G's. How many H's going to take out? 2. Because that's the least H's that I see anywhere. Does everybody see that? Everybody with me? So again, it really is just thinking backwards. Where would this have come from? What would somebody have distributed? So what's left in the first term? 2.
8.
No G's, I like it. You had 3 H's, you took 2, you got 1 left, I love it.
3.
3. You had 3 G's, took 2.
G.
G. Had 4 H's, took 2.
H squared.
H squared. 4's gone. G's are gone. H's are gone. So why is there a 1?
Because if you multiply that times
Yes.
4G, 2, whatever, yeah, place one number.
I like it. So one way to think of it is a placeholder. If I didn't have that there, could I get all 3 of these back? No. So when I multiply it out, I don't get the same thing. I'm wrong. Or, why is this 3? Because 12 divided by 4. I'm dividing the shit out. Something divided by itself is 1.
If I put 2, would be good. And
2 where?
instead of the 4, like 2 times 4 would be 8, and 2 times 6 would be 12.
Oh, okay. So watch. Okay. I love this question. So let's do this problem again, but instead of taking a 4 out, you took a 2 out. All right. That won't be wrong, it just won't be done. All right. So if I took a 2 out, because they all have a 2 in them, right? And then I took out still G squared, H squared, right? So now there will be 4H minus 6, like you said, GH squared, plus 2 now, right? How do I know I'm not done?
You can still take out a 2.
They each still have a 2. Just like reducing a fraction. Is every fraction you reduce, can you do it in one step? No. You do one thing, you're like, oh shit, they both still have a 2. Okay, go further. No big deal, right? If I take another 2 out, though, so if you stop here, you're wrong. You're going to lose points. Mainly because I'm evil, but is that cool? So now if I take another 2 out front is going to be 2 times 2, you guys. So there's nothing wrong with this. Just make sure you go all the way. So there'll be a 4 out there now, and everybody just decreases by 2. And we get the same thing, thank God. Do you see how it's just like reducing a fraction? Maybe you have to do a couple steps. I like it. Okay. So watch this. Let me see, what order do I want to do this in? Yeah, let's do this one now. Let me show you, here's a problem. I normally like scale problems up, harder and harder and harder. So I'm going to take a big step back, and then I'm going to take a big step forward. So what the shit am I going to do? I'm going to do this. Somebody help me out. How do you factor 4a, what do you gotcha? Minus 6a squared. I don't want to make this too weird. I think I don't want to do that. Oh, okay. All right, wait, let me make it different. So 2, yeah, this is 2y minus by. All right. So don't feel freaky. I told you it's easy. It's easy. What's the only thing that can come out?
Y.
Y. And what's left?
2 minus B.
2 minus b. Okay, that was easy. Now, the one I'm about to do is the same problem. Because what is y? What is y?
Variable.
A variable. So y is some number that I don't know yet.
Placeholder.
It's a placeholder for some value of a number I don't know yet. So watch. This is twice something minus b times that same thing. Right? So watch this. Here's twice something minus b times that same thing. Same problem. I know people think I'm crazy when I say that. Twice something minus b times that same thing. What is a plus 1? A number I don't know yet. What are these? How many terms are up here? How many terms are up there?
2.
2. 1, 2. What do they both have?
A plus 1.
I love it. Let me ask you this. Do either one of these terms have an a?
No.
No.
It's an a plus 1.
Yes. Now watch. So if I ask you 5 plus 7, do either one of these have a 2? No. Even though 5 is 2 plus 3, I don't give a shit. Because what is inherent in the way I'm saying this? It's got to be a factor. GCF, right? Factor. I like it. So neither one of these has a freaking a. They both have an a plus 1. So the same way these both had a y, so I took it out, I'm going to take out a plus 1. And what's left?
B minus
2 minus b, the same way. So it's basically the same problem. The thing we got to get over is this and this, they both represent some unknown number. So they're both going to work the same way. This is one thing the same way this is one thing. I like it. Okay. So as I'm talking, I'm working out the order I want to do things in. The book introduces an idea a little too early, but I'm going to do what the book does. So now watch this. Help me out with, here's an idea. This is an idea, and we're eventually going to bring in this whole GCF thing into this idea. If I had a number times a number, and I know the answer is 0. So if I multiply two numbers together, and the answer is 0, what's got to be true about at least one of the numbers? Yeah. If I put any other number there, if I knew a times b was 4, do either one of these have to be anything? Give me two numbers that multiply by 4. 2 and 2, that's crazy. What about 4 and 1? What about 8 and 1/2? What about 40 and 1/10? Right? How many answers are there to this? Infinite number. But this guy, the only number I could put here and actually know something for sure is 0. Because what's got to be true then? Either A is
0.
or B is 0. Now, I kind of like this order I decided to do this in because very much like we just talked about, what if the problem looked like this instead? You guys see how that and that are the same idea? A number times a number. A number times a number is 0. What must be true?
Relative to 0.
Either, huh?
One of the very x is
Yeah,
0.
either, no. If x is 0, what do you get?
Uh,
Negative 5.
Yeah.
I don't get 0, right? So not x is 0, but either this number is 0 or this number is 0. If x plus 1 is 0, then what's x plus 1 times? Who gives a shit? 0. If x minus 5 is 0, then what's x minus 5 times the other thing? 0, right? Let that sink in. The funny thing is, not funny, but some of us are going to foil this thing because there's a part of your brain that goes, oh, I know what to do, I'm going to foil it. When in reality, it's the opposite I want to do. I want to factor. Thank God this is already factored for me. Right? It's something times something. So what are the two answers? Negative 1. 5. I love it. Obviously, if x is 5, this is 6 times 0. 0. And if x is negative 1, this is 0 times negative 6. 0. So, here's where this creeps in. Now, this is really kind of a big step. Right? And of course, I know some of you guys have done this before, whatever, but great. The big step we're taking is I cannot solve that equation the same way we always have. Can I get all my x stuff into one term like we used to be able to? Right? I can solve this equation, no, who cares? I can do this equation. Why can I solve that equation? Because all my x stuff can be put together into one term. And then I divide by the number in front, I'm done, right? Now, we never really thought of it that way because we never had other powers of x in there to worry about. So here, can I get all my x shit together? No. You can't combine 5x squares and 10x's. They're not like terms. But can I use this idea? Yes. So if I factor that thing, I can do what we just did here. What comes out?
5x.
5x. And what's left?
X plus 2.
X plus 2. I like it. Everybody with me? So what are the two numbers I have multiplying? I have 5x, and I have x plus 2. So what's got to be true about one of those two numbers? Either 5x is 0, or x plus 2 is 0. So really, really realize what's going on. If x were 5, just to give a number, wouldn't this be 7? So that x plus 2 is a number. And of course, 5 times x is a number. So if these multiply to be 0, that one's 0 or that one's 0. That's the only freaking way that equation is going to work. Right? If I put an 8 there, holy shit, I could not do it this way because I couldn't make the list. It would take the rest of my life. Right? It could be 2 and 4, or 4 and 2, or 1 and 8, or 16 and 1/2, or 40 and 1/5, or holy shit. So the only number that works here is 0. That's why I think this book, I think some books call it different things. It's called the zero product property in most books. I don't know if it calls it that in this book. So if I have a product that is 0, then one of the two pieces has to be 0. So what's this become? I solve for x. Let me help you out a little bit. People freak out when there's a 0. X equals 0, or
X minus negative 2.
x equals negative 2. If x were 0, 5 times 0 is 0 times, who cares, is 0. And if x is negative 2, same idea. I like it. I like it. You would, Jeff. I know. So real quick, now watch this. This is our first little example of what to do when it's not 0. What if I have this in there? I like it. This is not good enough. This is stupid. Why is this kind of dumb? What would I do to solve this? We don't quite know enough yet to do what I want to do. Let me do this instead. Delete that. This I would just divide by 3, subtract 5, right? Because there's just an x. All right, let me make it a little more interesting. So forget about that. What you got, Jeff? Oh, yeah, that's right. So don't start saying x equals 4x or x minus 5 equals 4x. No. No. What's the only thing that could be here for me to do that next step? What has to be here? A 0.
You have to move 4x to the other side.
Yeah. So somebody factored this side before that side was 0. So what do? I unfactor this side, and then I subtract the 4x over. Now I got it equal to 0, right? It's got to be equal to 0 for this whole thing to work. Now how do I factor? What do I get here now? I get x squared minus 9x is 0. And then how do you factor that? What comes out of those two?
X minus.
Can you guys see the answer now? X is 0. Or x is, what makes it 0?
9.
9. How you check it, you put a 0 back at the beginning. 0 times who cares is 4 times 0 is, yay! So 0 equals 0. Put a 9 in. 9 times 9 minus 5. So 9 times 4 is 36. 4 times 9 is 36. 36 equals 36, yay. So you check it like you always would. Right? Okay, maybe. So, motivation for the next step then. I think one reason this book, see, I'm used to doing this kind of problem after we've done all the factoring methods. But I think part of the reason they did this so early is for motivation as to why the other factoring methods exist, possibly. So like, for example, I have no way right now to solve this equation. Some of you guys might know. Some of you guys might know something you cannot use yet because we haven't proven it yet. Starts with a Q. If I started off with this down from there, negative b plus or minus
Quadratic formula?
square, yes. I don't want to see any of that shit. It's officially, we don't know it. So don't do it. So I'd have to know how to factor this thing so I could do this kind of stuff. Because again, if that wasn't there, I could just solve for x. The minute that's there, I need a different way to do it. Because the old way will not work. I can't get all my x stuff together. I want you to really understand why we're doing things a different way. I have to make a new way to do it, because the old way won't work. Now, here's a really cool thing to realize. Whenever there was an x squared, how many answers have we gotten?
2,
If there was a cube, I would get...
3.
If there was a 7th power, I'd get... What happened? I get 7 answers. Throwing off my rhythm. Alright, so... I'd have to be able to factor this. Unfortunately, I need to go back. So, in a minute, we're going to focus on how to factor this. I'm going to take a step back. I got a little excited. I want to do this. It's so cool. Let me come back to this type of thing. Remind me how to factor this. So when the question says factor, factor is the opposite of multiply. You guys with me? If I said factor 18, you're going to tell me what would have multiplied to be 18. So if you're distributing or stuff when the problem says factor, you're more than likely wrong. It's very, very infrequently you would actually multiply. I want to unmultiply, right? Did we already forget how do we do this? How many terms are there?
X minus 2 squared.
No. Wait.
Two times
There are two terms. What do both terms have? Neither term has an x. You with me? Remember? Neither one of those has an x. Well, this one does. But this one doesn't also.
X minus
But they
2.
both have an x minus 2. Do you guys see it that way now? All right, that's a weird little thing that's got to click in your head. This has no x. And that's when students are like, Jeff, you feeling all right, man? No, there's an x minus 2. It's like saying this has a 5 in it. Because 9 is 5 plus 4. No. It's got a 3 in it, right? Ain't got no 5 in it. Yes. So I can take out an x minus 2. And what's left? 7x plus 3. So, somehow, this problem is connected to that one we just did. Now, before you put these together, don't. How many terms are there here? 4. 1, 2, 3, 4. Terms are always separated by pluses and minuses. The way that most math teachers teach factoring is the number of terms you see in a problem tells you what to do. You always try GCF first. Does anything come out of all 4 things? No way. All right, so what? If there's 4 or more terms, you do something called grouping. So can something come out of those first 2? 7 and x. So what I'm doing is I'm making like 2 separate GCF problems. Because what am I hoping is going to happen? Well, I kind of made it so it's going to become this, but I'm hoping it'll have stuff. So this has got a 7x, x minus 2. Is that cool? What comes out of this? 3.
X minus
And now you see they both have that x minus 2. You kind of uncovered what they both have. So then the last step is the same one over there. What if I wrote, instead of this, what if I wrote this? Is that all right? What's 6 times 8? 48. What's 8 times 6? 48. Right? So that's commutativity. It doesn't matter what order they're in. These are both right. You with me?
I have a question.
Yes.
What if the 3x was switched with the negative 4x on top?
Ooh, I love it. You ready? It's like I planted you there or something. So what she's saying is, what if it looked like this? The 3x was right here, and the minus 14x was there, right?
Yeah.
All right, here we go. So I still got 4 terms, so I still try to group. Is that dude still going?
Yeah.
Okay. Yes. All right. This is kind of nifty. There's a couple things going on here. Have you ever done this before, anybody? Anybody ever done grouping before? So sometimes teachers will show you put a parenthesis in there. Don't do that shit. Because if I put a parenthesis here, I took a negative out, it gets all wonky. Just underline the damn things. What comes out of these 2? Just an x. What's inside?
7x
7x.
plus 2.
It's hot in here, right? It's not just me. Is it just me? Is it hot? It's all okay. So what comes out of these 2 things?
A negative.
Yeah, now notice. Why could I do this last step? Why could I do this step here? Because this was exactly the same as this. This is kind of cool. This is the problem giving you a little hint. All right, what's got to show up here then? Freaking positive 7x, right? It's got to be the same. This has got to be the same as whatever is here. So what must I take out? So this is a 7x. I've got to take out a negative 2. And what's negative 6 divided by negative 2? Now what I get is people make a mistake on the sign and somehow they do the next step. What right here tells me I've done something wrong. I can't do the next step. This and this
Should be the same as the original.
have to be the same. They're not the same. I know there's a mistake somewhere, right? But some people just go, just throw everything in, right? These have got to be the same or else the next step doesn't make sense. So most often it's a negative mistake that people make. So what can I take out? 7x plus 3, and what's left? X minus 2. What's really neat is, what's on the inside on this step? X minus 2. And what's on the outside? 7x plus 3. Now what's on the inside? 7x plus 3. And what was on the outside? X minus 2. Did I end up in a different place? No. Same answer. Maybe. All right. So, let me give you this worksheet. We're going to work on, there's a side 1 and a side 2. It doesn't say side, it says 1 and 2. Do the 1. In fact, find people near you to at least sit next to and pretend like you're working together, or maybe even work together, for real. I'm gonna let you do this all on your own, and then we'll talk about it. There's even some stuff to read on this thing. Stay with me. Just to help you real quick with the first part of this. This is something you could have done like back in Math 88, the first step of this. Can you give me two numbers that multiply to be 20 and add to be 12? So like 4 and 5 multiply to be 20, but they add to be
10 and 2.
9, right? So 4 and 5 is not the right answer. What is it?
10 and 2.
Yeah, 10 times 2 is 20, and 10 plus 2 is 12. So that's what I'm asking on those first few problems. Right? So try to do this worksheet step by step. The first few steps are old news. Right now, yes, right now.